In this video, I'll be going over 3 free response questions for AP Calculus BC. These 3 require a calculator for some of them. So have your graphing calculator out. Okay, I took these from just a test prep book, a very ancient one, but the topics are the same. So I thought these are still pretty good practice problems. And just in general for AP Calc BC students, if you just need more practice on free response questions, of course, you can go to the AB videos, AP Calc AB videos, and get some practice on those as well, because you need to know the AB stuff as well. And there are different questions on the AB mock tests. Okay, so in this video, there's just a few that are, I think there's 2 problems that are actually BC topics. One or maybe just one, actually. So anyway, so my point is if you need more practice in general for free response questions, go try the AB ones as well. They might not be specifically on the BC topics, but regardless, they should be good practice because you need to know this stuff, those topics anyway. Okay, without further ado, let's begin with problem 1. Here it is. So please try the problem first on your own. Pause the video, work this out first on your own, and then unpause it to check your work. And of course, if you got totally lost, you can see how I think through the problems and what concepts you need and all that. Okay, so go ahead and try this one. Okay, so this is a BC topic, Taylor polynomial, Taylor series, all that stuff. So this one says let f be a function that has derivatives of all orders for all real numbers. So it's just basically saying it's differentiable. Okay. Assume f of 1 is 3, f prime of 1 is -1, f double prime of 1 is 4, f triple prime of 1 is -2. So just from this, you can probably tell that we're going to need a Taylor polynomial about the center of x is equal to 1, probably. Okay. Part A, find the 3rd degree Taylor polynomial for f about x is equal to 1 and use it to approximate f of 1.1. Okay, so in general, we should scan through all the problems first, because especially for the calculator ones, you might want to input the function as your y's, your y1, y2, y3, whatever. You might want to do that ahead of time. Okay, part B, write 2nd degree Taylor polynomial for f prime about x is equal to 1. Use it to approximate f prime of 1.1, okay? Part C, write the 4th degree Taylor polynomial for g of x's integral from 1 to x of t dt. Part D, can f of 2 be determined from the information given? Justify your answer. So part A, we're going to write the 3rd degree Taylor polynomial. Okay, so we need to take derivatives, but they give us the values already. So we just remember the formula for a Taylor series, and we cut it off at the 3rd degree term. The Taylor series is the infinite power series. Taylor polynomial, we just cut it off to a finite degree term. So 3rd degree, we cut it off at the 3rd degree term, or the x cubed term, basically, okay? Or x minus a cubed term, where a is the center. All right, so let's find it. This is the formula for the Taylor polynomial, centered at 1. Okay, so we need f of 1, which is 3, f prime of 1, which is -1. We need f double prime, which is 4, and f triple prime, which is -2. And then we can simplify a little bit. Honestly, in the AP exam, this line right here, let me even highlight it with my cursor. This line right there should be sufficient, okay? And you might want to put this in your calculator, or you could simplify a little bit and input this next line as if you want. Both are acceptable. Of course, there's risk for error if you try to simplify, even though this is pretty easy. So I would just box this as your answer for the 3rd degree Taylor polynomial, okay? Now we're going to use this guy to approximate f of 1.1. So we put it in our calculator, this guy or this guy, and then we just find out when we plug in x is 1.1, and then that is our approximation to f of 1.1, okay? So that's what I said here. Set y1 as your 3rd degree Taylor polynomial, because we'll need it in the next parts as well, and then use your calculator to find it's 2.9197. So therefore, f 1.1 is approximately 2.9197. Box that. So box this and box the Taylor polynomial. Okay, part B, write a 2nd degree Taylor polynomial for f prime about x is equal to 1 and use it to approximate f prime of 1.1, okay? So remember, we can differentiate and integrate power series, okay? So our T3 in the previous part was the Taylor polynomial for f, okay? So if we differentiate T3, so T3 prime, that will be the Taylor polynomial for f prime, okay? So that means f prime of 1.1 is approximately equal to T3 prime of 1.1. Okay, the concept here is you are able to differentiate and integrate power series. So T3 is an approximation for f. So to get approximation for f prime, just differentiate T3. Okay, so we differentiate, and yeah, you probably need to write it. So you probably should at least say d by dx of T3. I just put the whole thing because I copy pasted. And then after we differentiate, you should get this. Okay. And then we can find f prime of 1.1. So we plug in f as 1.1 here. We should get minus 0.61. Or if we use our calculator, we can do n derive y1 comma x comma 1.1. The derivative of y1, which was our t3, with respect to x, evaluate at x is 1.1. So you can evaluate like that, or you can type this, but plug in x is 1.1. Honestly, I would probably do the latter, this n-derived one. Okay, part C, fourth degree Taylor polynomial for g of x is this guy. Let me reformat this. I don't like how this is looking. There we go. Okay. Apologies. Okay. So remember in part B, I was saying you can differentiate and integrate power series. So we can just integrate our T3 to get G. Because what does the fundamental theorem of calculus say? If we differentiate both sides, G prime of x is f of x. So to get back to G, we just integrate f. And as I was saying in the other part, since T3 represents f, or approximating f, I should say, which is the derivative of G, that means to represent G as a Taylor polynomial, we just integrate T3, okay? So that's what I did over here. I just replaced the x's with the t, okay? So that we can get the definition, okay? Now, just do the power rule. For this one, I think you gotta do this by hand. So this is the power rule and the fundamental theorem of calculus, okay? So the important part, I don't know how picky the graders are, honestly, for the AP exam, but if you stop here, you might get a point off. Let me highlight it, this line right here. You might get docked a point. Why? This is not a typical power series representation or Taylor polynomial representation. Why? Well, here it's centered at where we want it at, okay? However, this is not at the same center. It's at 0. This term is centered at 0. All these other terms are centered at 1. Actually, this is also centered at, well, technically this one doesn't matter because something to 0 power, so that's fine. But this is inconsistent, basically. So we can just group 3x minus 3 together and factor out a 3. So then it matches the form, the typical form, typical notation. Okay, so again, I don't know how picky the graders are. I haven't looked at the scoring guidelines, to be honest, but this is how you should write it, in my opinion. This is the typical power series representation with the center everywhere versus this is a different center. Okay, part D. Can f of 2 be determined? No, we cannot. Nothing's given about f of 2. Maybe we can approximate it with a linear approximation or use the Taylor polynomial to approximate since we know all these guys, but we don't know f of 2. We can only approximate it. Okay. Problem 2. Actually, let me go back to this real quick. I don't know what they're expecting for justify your answer, to be honest. So I wouldn't worry about too much about this problem and how to show your work, but just how to think through it is we really aren't given any information. We could just approximate it. Yep. Problem 2. Consider the differential equation, the sky. Find a solution to it that satisfies f of 0 equals 2. That's part A. Part B, what's the domain? Part C, for what value or values of x does f have a point of inflection? So go ahead and try this one on your own. Okay, so this is not a BC only topic, so even AB students should be able to do this. How do we solve this? How do we find a solution to this? Well, we can use separation of variables. That's really the only technique I believe that you learn in AP calculus, whether AB or BC. You don't know about linear equations and integrating factor and all that stuff. So you have to use separation of variables. Okay, so we move all the terms with y on one side, move all the terms with x to the other. That's what I did here. And then we integrate both sides. So then the left-hand side is just e to the y. And then the right-hand side we use the parabola is x cubed plus x squared plus c. Okay, some formatting issues again. I don't know why it did not save properly. But anyway, so you could just find y directly from here. I decided to just find what c is first, use the initial condition to find what the c is. Okay. We need a particular solution because they gave us the initial condition. It's not asking for the general solution. So technically, the wording of this problem is incorrect. It should be find the solution that satisfies this. But anyway, okay. So we plug in y is 2 and x is 0. Okay. And we get that c is equal to e squared. So our solution is e to the y is x cubed plus x squared plus e squared, but we need to solve for y because it asks for y equals something. So we just natural log both sides. So y is ln of x cubed plus x squared plus e squared. Okay. Part B, what's the domain of f? Well, we got this is our solution, our f. I just called it y here. So how do we find the domain of this guy? Well, we know that the inside of the log must be greater than 0, okay? So this is the inequality we just solved. We just use the calculator. We graph this guy. We see when it crosses the x-axis and is positive onward. That's at x is minus 2.344. So the domain of f is x is greater than minus 2.344. Don't put equal, because what's log of 0? It's undefined. So don't put the equal sign. Part C. For what value or values of x does f have a point of inflection? When do points of inflection occur? When the second derivative changes sign. So we need the second derivative. Okay. The problem is it's kind of hard to differentiate right here. It's actually, we would need implicit differentiation. And then we need the quotient rule and all that stuff. Okay. Or even if, since the calculator allowed, if you want to do n derive, how do we do it with respect to both y and x? That's the problem. This is not just in terms of x on this right-hand side. It's both x and y. So we got to make this e to the y in terms of x somehow. And how do we do that? Well, this is where this came into play over here, if you pay attention to part A. E to the y is x cubed plus x squared plus e squared. Okay? Or since you had it here, you can just exponentiate both sides to get back that as well. You can think of it like that as well. Okay? But anyway, so where was I? Over here. Okay? So that's what I'm saying here. E to the y is x cubed plus x squared plus e squared. Okay? So we replace this e to the y with this over here. So dy dx is now all in terms of, is a function of x only now, okay? So now we put this as y1 in our calculator, and then y2 is the derivative of y1. So n derive y1 comma x, okay? Or this right here, depends on the calculator you have. When I was learning how to use the calculator, I have the older versions where it was n derived and didn't have this differential notation. But anyway, so So we're going to graph y2 and see where it changes sign, because remember, as I said, or as we should know, actually, points of inflection occur when the second derivative changes sign. So what does it change sign? It changes sign here and here. Went from negative to positive, positive to negative. So the values are minus 0.331, 2.128. Box those two. Okay. By the way, to show our work, I haven't really said that. I'm just sharing how to think through the problems. Again, it depends on the scoring guidelines. I didn't look at it, but what I personally think is important to probably show is this right here. Okay. And then you might just want to say the second derivative changes sign at these 2 points, something like that. Okay. Problem 3. This is not a BC only topic. If for some reason you're in AP Calc AB and you're watching this video, maybe you still self-studied yourself, self-studied the BC topics yourself. That's great. But anyway, let R be the region enclosed by the graphs of y equals minus x squared plus 3 and y is inverse tangent x. Part A, determine the area of R. Part B, write an expression involving one or more integrals that gives the length of the boundary R. Never mind, this is a BC topic. Part B. Okay. Do not evaluate it though, so we just have the integral. Part C, the base of a solid is the region R. The cross sections perpendicular to the x-axis are semicircles. Write an expression involving one or more integrals that gives the volume of the solid. Do not evaluate. Okay. So how do we get area between curves? If we take vertical slices, it's upper curve minus lower curve. So let's graph these on our calculator since we are allowed a calculator. This is the parabola, this is the arctangent, inverse tangent, okay? So this is the region up here, okay? So upper curve is the parabola, lower curve is the arctangent. What are the limits of integration? We need the points of intersection, use the calculator to get those. It's at x is minus 2.028 and x is 1.428. So we separate integral from minus 2.028 to 1.428. By the way, you should store these as variables in your calculator. Okay. y1 minus y2. Well, I guess I didn't say this yet. y1 is set to the parabola. y2 is the arctangent. Okay, so y1 minus y2 dx. So in the calculator, this is 7.2428. So if you have the older ones, it's f int y1 minus y2, comma x, comma minus 2.028, comma 1.428. That's how we input it. Part B, this is asking about the arc length, the length of this boundary. So we need to set up two integrals because we need to trace the arc length of the parabola, and separately, we need to trace the arc length of the arctangent function, okay? So we got to remember the formula for the arc length, it's just this integral, okay? So to get the length of this parabola, we need to, since this is asking us to set up the integrals, not valid, we got to find the derivative by hand, which is simple enough, because it is what? Minus x squared plus 3. That's our parabola, so the derivative is just minus 2x, okay? So the length of the parabola, that side, is the integral from the same limits as before, because we start here and stop there, okay? Square root of 1 plus parentheses minus 2x squared dx, okay? That's how we set up the first one. And the second one, we just need to differentiate the arctangent. What's the derivative of arctangent? That's 1 over 1 plus x squared. Then we plug that into the formula. So the total length is the two integrals. This would be the answer that you box. I don't think you need to go simplify this, but it's easy enough, 4x squared. And then I wouldn't bother simplifying this, to be honest. Okay. You should be able to get the points just from this, in my opinion. I'm pretty confident, I should say. Okay, they don't really care too much about simplification, if I remember correctly. All right, part C. Okay, the base of a solid is the region R. The cross sections perpendicular to the x-axis are semicircles. Write an expression involving one or more integrals that gives the volume of the solid. Do not invalidate. Okay, so the way to do these is perpendicular to the x-axis. So we're going to probably want to step our integral in terms of x or dx. So it's area of the cross-section is CS, times dx. So we need to express the area of the cross-section. The cross-section is semicircle, so what's the area of a semicircle? For a full circle, it's pi r squared. Yeah, so semicircle is half pi r squared. So now we got to find out what r is. Well, the diameter is right here. That's why we sketched the representative semicircle. Okay. This is the diameter. What's the length of this diameter? It's this upper curve minus the lower curve. So the parabola minus the arctangent. Okay, that's the diameter. So the radius is just half of that. Okay, so diameter, as I was saying, is minus x squared plus 3, the upper minus the lower, which is the arctangent. Radius is half the diameter, so we plug everything into the integral. It's half pi. This is our constant, so I pulled it out. Integral from the limits are the same, start and stop. Okay, the minus 2.028, 1.428. And then we need the r squared, which we said was this guy over 2 squared, and then dx. That's just pretty easy if we know how to think these through. All right, that's it for this problem set, this mock test per se. Hopefully this was helpful and you got some good practice in. Please give this video a like if this has helped you in any way, and hopefully I'll see you in another video as well. Bye.